This is the help video for determining the probability of two independent events. And we're going to start with determining the probability of just one event. I have a spinner with 3 equal spaces on it. So for writing probabilities, that's the number of possibilities I have that make up one whole spinner, and they're all equal amounts. And one of those is blue. So I have to say I have a 1 in 3 chance of spinning a blue. So there's one, and it doesn't always work out. It's just a theoretical chance, but I got it on the second try, not bad. And I'm at a 1 for 3, so I got 1 out of 3 just using my first 3. And what this also means is if I rolled 30 times, I should get 10. If I roll 300 times, blue should come up 100 times. 1 in 3 probability. Let's make it a little more interesting. What's the probability of two independent events? Now, the two phrases we're looking at are or and. On this one, they're asking what's the probability of it landing on blue or the die landing on a 3. So let's see here. But just one die, not 2. So for the spinner, it's a 1 in 3 chance. For the one die, it's actually... there's 1 3 on it. There's 6 sides and 1 3. So I have a 1 in 6 chance. So what is my probability? Is it better than 1 in 3? Well, let's see. It should be, because if I land on a blue, I've already won. If I don't land on a blue, I still have a 1, and that's a 1 in 3 shot. I'll land it on again. If I don't land on the blue, I still have a 1 in 6 shot of rolling a 3. In that case, I didn't do it. So what are my probability? It is better than 1 in 3, but exactly what is it and how do I find it? So the 1 in 3 for the spinner and a 1 in 6. And when it says the key word here is or, it means I can get either one. It increases my chances. So I add these together. Now I have to write these as equivalent fractions to add. 6 is my common denominator. 3 times 2 is 6. So 3 times 2, 6 is 1/3. Plus 1/6. Then that equals 3/6. And I can simplify that to 1/2, or 1 in 2 chance. So the odds are pretty good here. I got a 1 in 2 chance. Let's look at when I use the word and here. Is it easier or harder when I use the word and heads? So let's take a look. So I have to roll on this one. I have to roll a 4 out of 6 and also get heads. So that is a 1 in 6 chance. And I have a 1 in 2 chance. Okay, so I have to get them both. So if I don't roll a 6 on this, I've already lost. I'm flipping the coin as well. I already lost. It doesn't matter what this lands. It landed on tails anyway, so I really lost. Let's try it again. Oh, 1. This has to be on a 4. And I got the heads, but I lose because I get the 1 in 2 chance. Now, what's the probability of getting a 4 on this spinner of 6 or 1/2? And 1/2, excuse me. I have to get them both. So let's figure out that math here. It is, already got it for you here. When it's multiplying. So it's 1/6, and that gets cut in half. I have 1 in 6 on the spinner, but that gets cut in half by the probability of the flipping the coin. So if you see the word and in probability, it means multiply. And use top by the top, bottom by the bottom. So 1 times 1 is 1. 6 times 2 is 12. So I have a 1 in 12 chance on getting this with a 6. 1 out of 6, 1 out of 2, 1 in 12 chance. Let me try one more time for you. Keep your fingers crossed. I got a 1 in 12 chance here. Didn't get it. Oh well. Wah, wah, wah. That's been, if you need help with this, see Mr. Jarvis, or you can watch this again and give it another try.